this is Calculus 12, Chapter 3.3. This is an extra section on how to do some extra problems. We're going to take a look at the multi-product rule. This is a handy rule, and it's easy to generalize. So we're going to take the derivative of u times v times w. We already have a rule for uv, so that's why I put it in brackets. We want to use the product rule on this factor and this factor. So we're going to do d dx of uv times w. So we're doing the derivative of this times this. And we're going to add this to uv times w prime. So this is the product rule. Now we're going to substitute. Product rule of uv is u prime v plus uv prime. And then we're still multiplying by w. And we can just remove the brackets for this multiplication, uv w prime. And we distribute w into this. We get u prime v w plus uv prime w plus uv w prime. I hope you see the pattern there. And we have the product rule here. But in case you don't see the pattern, we're going to do one more. We're going to do the derivative of u times v times w times z. We just found the derivative of u times v times w, so we're going to put that in brackets. So we're going to do the derivative of u times v times w times z plus u times v times w times the derivative of z. Again, we're using the product rule here. The derivative of the first times the second plus the first times the derivative of the second. And we substitute. We're going to substitute the product rule. This is the derivative of the first. U prime v w plus u v prime w plus u v w prime times z. Plus, and we're just going to take away the brackets, u v w z prime. Now we're going to distribute z into each term. So we have u prime v w z plus u v prime w z plus u v w prime z plus u v w z prime. Hopefully you see the pattern now. We have the derivative of the first factor times the rest. The derivative of the second factor times the rest. The derivative of the third factor times the rest. The derivative of the fourth factor times the rest. So generalizing, we take the sum of the derivative of each factor multiplied by the rest of the factors. And let's just go over this one again. We have u prime v w, so the derivative of the first times the rest, derivative of the second times the rest, derivative of the third times the rest. So let's look at some common misuse of the product rule and quotient rules. So the derivative of 4 sine x. So some people like to do this, d dx of 4, because they are using the product rule here. And times the second, sine x, plus 4 times the derivative of the second factor, sine x. Okay, again, we are using the product rule. So some people will mistakenly forget this second term in the product rule and just do the first term. they end up with 0 times sine x, and leave it at that, which gives you 0, which is incorrect. We need the second term, 4 times the derivative of sine x, that's cos x, and we're left with 4 cos x. Okay, this is extra work. You just don't need to do it. Use the constant multiplier rule. The derivative of c times f of x is c times the derivative of f of x. And that is just this. Okay? We're taking the constant multiplier, multiplying the derivative of the function. It's not wrong to do this, but it's a waste of time. Okay, here's another example. We have a constant here, and people will use the quotient rule. Again, it's not a problem. It's just extra work that you don't need to do. d dx of -3. So the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. All over the denominator squared. So carrying on, we have 0 times cos x plus 3, and the derivative of cos x is negative sine x, all over cos squared x. And what we want to do is rewrite this. This is 3 over cos x, and -3, we'll take the -3, and then we'll have sine x over cos x. This is a multiply. This is 0, so we don't include it. And now we have -3, and this is secant x, and this is tangent x. Okay, that's a perfectly valid solution, but it's extra work. So what we want to do is we want to rewrite this using identities. So this is d dx of -3 secant x. Rewrite using identities. Okay, and we can jump to our answer, -3 secant x tangent x, and this is just a derivative rule. You haven't gotten there yet. It's coming up in a later section in chapter 3. Let's look at one last example. Again, we'll use the quotient rule, d dx of 4 times the denominator, x cubed, minus 4 times the derivative of the denominator, that's d dx, x cubed, all over x cubed, squared, that's the denominator squared. This leaves us with 0, the derivative of 4 is 0, times x cubed, minus 4. The derivative of x cubed is 3x squared. And we have x to the power of 6 in the denominator. This goes away. We can simplify this to -12x squared over x to the power of 6. And this simplifies to -12 over x to the power of 4. Okay, what's a better way to do this? Well, we can rewrite this. This is d dx 4x to the power of -3. Okay, so anytime we move power from the numerator to the denominator or denominator to the numerator, we negate the exponent. And now we can just use the power rule. Now we're going to use the constant multiplier rule too. We're going to take the 4 And then we do the power rule, -3, x to the power of -4. We simplify this. This is -12. Again, we're going to move the denominator into 0, and we're going to negate the exponent. And we have identical answers. And that completes this lesson.